Our heading for today is grade 11 analytical geometry. Grade 11 analytical geometry. Alright, the only new concept is what is called the angle of inclination. The only new concept is what is called the angle of inclination. So our new heading is angle of inclination. Okay? Now, first thing you need to know that this is a totally new concept to you, but you have a bit of some background with regard to what inclination is all about in terms of calculating gradient using trig ratios to find the size of an angle, right? So first thing I'm going to define what is an angle of inclination. The angle of inclination the angle of inclination is an angle between the x-axis and a straight line. Okay? So the angle of inclination is an angle between the x-axis and a straight line. Right? It is measured from the x-axis in an anti-clockwise direction. It is measured from the x-axis in an anti-clockwise direction. That's what I'll show you. Right? Okay, so you measure the angle from the x-axis in an anti-clockwise direction. Okay, so your starting point is the x-axis, right? All right. Now it's very important. I'm just going to highlight some very important points here. It is an angle between. This is very important. This line is very important. Okay, those words. It's an angle between the x-axis and the straight line. Also, it is measured from the x-axis in an anti-clockwise direction. It is not measured in a clockwise direction. Okay? So on the next page, I'm going to draw some diagrams on the Cartesian plane just to illustrate what I mean when it comes to the definition of the angle of inclination. Now, you have to know angle of inclination because it is always tested in examination, and when you write in a trick, it always counts. Right, so next year when you are in metric, you are going to see questions on angle of inclination. All right, there are two cases, right? So let's talk about the two cases now. So case one, the first case is when the gradient m is positive. And let me use a different color. So case one, m is greater than 0. Right? I hope that you are all aware that m stands for gradient. So when I write m is greater than 0, I'm referring to the gradient. Right? So what happens is this. If you have a straight line, say, right, let me draw it like this. If I have a straight line like that, okay, this angle, let me use this angle here, okay, that angle there is called the angle of inclination. It is an angle between the x-axis And when you measure from the x-axis in an anti-clockwise direction. All right? So I'm going to represent it by theta. Okay? I hope you are also aware that if you see a straight line like this, which is slanting to the right, it means the gradient is positive. So here, m of this straight line is positive. Therefore, if we want to find the angle of inclination, we use this formula, right? It will be tan theta is going to be equal to the gradient. Tan theta is going to be equal to the gradient, right? Whereby this m, so you need to remember this formula. Now we can simplify this and write theta will be equal to shift tan of m, right? So you can memorize it like that. And I prefer the first one though. Right? If you want to calculate this angle here, this angle, you use that formula, right? The first one. I'm sure by now we should know that the first formula tan theta equal to m. If you want to calculate theta, it becomes theta equal to shift tan of m. Now you need to remember that where m is equal to y2 minus y1 over x2 minus x1. You have done this from grade 9. So the gradient m is the same as the way that you calculate it. Okay? You need 2 points on a straight line for you to be able to calculate the gradient. Alright? So this is the first case where the gradient is negative. Okay? The first case is when the gradient is negative, like in this case. Right? You are most likely, in fact, always when you write your analytical geometry in grade 11, there will be a question on angle of inclination. When you write metric, there will be a question on angle of inclination. Always comes. Right? So make sure you are aware of it. Now, it is very important for you to know the definition of angle of inclination. Okay? It's an angle between the x-axis and a straight line, and it is measured in an anti-clockwise direction from the x-axis. Right? Right. So this is case number 1. Now, case 2 is when the gradient is negative. Right? Now, when the gradient is negative, the equation to calculate the angle of inclination changes slightly. So now we have got m being less than 0. In that case, we are going to have a scenario like this. In that case, we are going to have a scenario like that. So, our angle of inclination is going to be this angle now. This is going to be our angle of inclination. I'm going to represent it by theta, whereby the gradient is now negative. Okay? So this is x, that's y. Okay? Now, if you want to find this angle, it will be an obtuse angle, which means it's between 90 degrees and 180 degrees. So instead of using the formula that I gave you on the previous page, the formula is going to be different slightly. So that formula is going to become theta is going to be equal to shift tan of m. Now, when the gradient is negative, shift tan of a negative angle will give you a negative acute angle. Now, the angle of inclination is always positive. It's never negative. Therefore, we add 180 degrees. This comes from the general solution. Okay? We add this 180 degrees in order for us to make the angle of inclination a positive angle. Because if this m here is negative, it means the reference angle we will get here is going to be a negative angle, which is acute. Therefore, we have to convert that negative acute angle to a positive angle by adding 180 degrees. Okay, and we have discussed this under trigonometry. Okay, so that would be your formula. Now, this formula for case 2 is not provided in examination, but the formula for case 1, this one here, it is provided. So it is your responsibility to memorize that one. If you don't use this one directly, it means you have to use this formula. Once you get your negative angle, you convert the negative angle to a positive obtuse angle. Okay, I'll show you just now when I'm doing some examples. Any questions so far? Right. All right. So the first question says, calculate the inclination of each of the following straight lines. Right? We just want to calculate what is the angle of inclination between this straight line here and the x-axis. Right? So if I take A1 for example, the equation is y equal to x plus 3. So the gradient is the coefficient of x. So m is going to be 1. So based on the formula tan theta equal to m, means the angle of inclination theta is going to be shift tan of 1, which gives me 45 degrees. Right? So what this means is the angle of inclination between the x-axis and that straight line is going to be 45 degrees. If you want, you can draw like a sketch, but I'm not going to do that because you have to draw this line y equal to x plus 3. Remember, you are in grade 11, you are expected to know how to draw straight lines, right? So this is the one with a positive angle. Then I'm going to do another one with a negative angle, like number 3 and number 6. Number 6, the equation is not in the form y equal to mx plus c. Right? So let me start with number 3. Number 3, we have y equal to square root of 3 times x plus 4. Right? So this means that the gradient is going to be square root of 3. For you to find the angle of inclination, you need to know the value of the gradient. So what this means is that tan theta is going to be m, and then theta, since the gradient is positive, means theta is going to be shift tan of m, which is square root of 3. So what's that value equal to? What is shift tan of square root of 3? It gives you 60 degrees. So the angle of inclination between that straight line and the x-axis is going to be 60 degrees. Right? Then let's do number 6. Now number 6 is 5x plus 3y equal to 10. Now that straight line is not in the form y equal to mx plus c. So I actually have to rewrite that equation. So number 6 is 5x plus 3y equal to 10. Right? So first thing, I need to make y the subject. So I'll take the 5x to the right. So it becomes 3y equal to minus 5x plus 10. And this will give you y equal to minus 5 over 3x plus 10 over 3. Right? So the gradient here is negative 5 over 3. You cannot determine the gradient of a straight line unless the equation is in the form y equal to mx plus c. Okay? Please remember that. Okay? If the equation is given like this, the coefficient of x is a 5, That's not the gradient. The gradient is coefficient of x when y is the subject of that equation. Okay? So from here now I can say theta is equal to shift tan of negative 5 over 3 plus 180 degrees. What answer do you get? 120,96 degrees. Okay, remember your final answer must be an obtuse angle. That is an angle between 90 and 180 degrees. Okay, always. And your angle of inclination, either it can be acute between 0 and 90 if the gradient is positive, or it can be obtuse if the gradient is negative. Okay. Then, but you guys got any questions? Or any calculation. In that case, you have to apply all your knowledge of geometry, that is analytical and Euclidean. So in this question it says determine the size of angle beta. Now, based on the definition of angle of inclination, is beta an angle of inclination? No. What that means is you have to calculate the angle of inclination first of these two straight lines. Okay, now it's going to depend on how you want to calculate. If I want to calculate this angle, right, this angle here, that would be an angle of inclination, right? Also, if I want to calculate, say, this whole angle here, it's not an angle of inclination, right? But I know that if this straight line here, that is BC, is perpendicular to AC, means this angle is going to be what? 90 degrees, right? But our angle of inclination with a positive gradient is going to be this angle here, right? But we want to find the size of this angle. What that means is there are many ways of carrying on. Okay, either I can use triangle ABC, or I can create a new triangle, say this triangle here. Maybe I can call it A, then whatever point is there, and a point there. Okay? But it means in any case I still have to calculate the size of this angle. Right? So this question, it requires some thinking, and there is more than one way to go around it. And I'm also going to show you how to answer the question based on a construction. But that's an option B now, in terms of doing the question. So, if you want to find the size of beta, the first case, you know that in triangle ABC, this angle here is 90, it means you have to find the size of this angle. Right? So what that means is, you may have to determine the angle of inclination. Okay? Determine the angle of inclination. Actually, two angles of inclination. The first one, it will be this whole angle there. Or rather, not that one. Sorry. It will be this one here. Find the size of that angle. Right? Then, you may also have to determine, let's see what color we try to. You may also determine this angle here. So, okay? Yes? Or you have to shift the graph. What? To shift the graph. Shift the graph? Yes. Well, if you can come up with a method where you shift it, then it's fine. Okay? But I'm not going to try and shift it at the graph. So, it means I can find the size of this angle. All I need is the gradient of this line to find that angle, right? But remember, I need to find the beta. Okay? So if I want to find beta, I may need to know what is the size of this small angle here. Now, that angle may be easy to find, because if I can find this angle here, it's going to be equal to that angle. Do you see what I'm saying? So it means I have to find the size of this, the green one, then I have to subtract it from 180 to get this angle here. They need to be equivalent to that because they are vertical what? Opposite. Also, I need to find the size of this angle here. Now, in my case, I'm not going to use this straight line here. I'm going to find this angle, right? Or rather, okay, if I do that, I may end up complicating things. Let me find the size of that angle. Right, let me label this point here. We've got AB, so ACB, so I can call this point D. Okay? I'll call it point what? Point D. You're allowed to do that. Okay? So, first thing, I'm going to calculate the size I'll call it CAD. Okay? Yes?
So you made a triangle ACD now.
Yes, I've already
Would
said.
it not make it left? No, sorry. We'll make an isosceles triangle with this one.
There are no legs here, so don't make an assumption. Don't make an assumption. So, the gradient of AC, do you agree with me that it's a 1? Right? So, it means angle CAD is going to be shift tan of 1, which is 45 degrees. Do you agree with me then? Huh? So, this whole angle here is going to be 45 degrees. But don't assume that this small angle here is 45. It's not 45. You have to prove that it's 45. So, in order for me to calculate the size of this small angle here, it's equivalent to that. So I'm going to calculate this small angle in green. But is that going to be possible? Huh? Do I know the gradient of this line? I don't know. Okay? I don't know. So, yes?
So if you break up that angle now, what is the angle on a straight line on the x-axis?
Okay. Be very careful. Since I found this is 45, right, I'm saying to find the green angle. That's an angle of inclination. We need to know what is the gradient of this line. You can't subtract 45 and then you say that's equivalent to that angle you give. Right? Now, I hope you are aware that since I got this angle as 45, this is 90, it means I can find the size of this angle. Am I right? Yes. Huh? I can use sum of angles in a triangle. Which means this angle here, right? It's an exterior angle of triangle ADB. It's an exterior angle of what? Triangle ADB. Which means in any case, I still need to find the size of this small angle. But the problem now is we don't have a gradient for that line. But can we find the value of x here at A? How can we find the value of x at A? Substitute y got what? 0. Thank you. So at A, y is equal to what? 0. So if I substitute into that equation, y got x plus 3. If I put x equal to 0, I'll get 0. So y equal to 0, I'll get 0 equal to x plus 3. So what this means is my x at A is going to be negative 3. Therefore, I can find the gradient of AB because this point here is minus what? 1. Minus 1. So the gradient of AB is going to be, okay, if my y is 0 here, it means it will be 0 minus the value of y here, that's negative 1. My x there, it's minus 3. The value of x here, it's a 0. So I'll get 1 over negative 3. So it's going to be negative a third. You following that? Yeah, the question requires you to think and apply the concepts. right? So now I can say that angle, let me call it theta, is going to be this. You can use theta, you can use alpha, because we already have beta. Okay? So theta is going to be shift tan of minus a third plus 180 degrees. What answer do you get? 161.5? 7 degrees. Are you following? Huh? Yes. So once you find this angle, this whole angle here, right? I can subtract it from 180 degrees and I'll get the size of that. Which means I can say DAB is going to be 180 degrees minus 161.57 degrees. And the answer there is going to be DAB is going to be equal to what? 18.43 degrees. Right? The reason for this is because this angle here, sorry, this one here, the small one, it's vertical opposite to that. They are vertical opposite. That's why we got that. So now that I know that this angle is 18.43, I've calculated this angle here, and it's 45, right? And this angle is 90. It therefore means that I can say beta will be equal to 180 minus 90 degrees plus 45 degrees plus 18.43 degrees. What answer do you get there? 26, okay? So that will be the value of beta. Okay? But that's not the only way. We could use, see this angle here. It's equal to the sum of beta and this small angle. So you can also use the exterior angle of the triangle theorem. Okay. All right. So for today, I'll stop here.